is you say, okay, this is just like my function. It's just like my a sub n is really like a y, and my n is really like a x. And when they want the first 5 terms, different books will do different things. Sometimes they start counting at 0, and sometimes they start counting at 1. I'm going to assume we're going to start counting at 1 since that's what the book does here, and I don't want to. So I know those Khan Academy videos, did he start counting at 0 or 1 when he was doing stuff? Do you remember?
I think it was 0.
Well, sometimes he started from 1 and sometimes he started from 0.
Okay. There's a way to show that, when they have that little notation where they've got the little, funny looking E. When they're going to add things together, they'll tell you if you're going to start at 0 and 1. In this book, we assume we start at 1. So, okay, so we got this kind of like a function here. What you can do if you want the first, they kind of do this. A of 1 would be the first term, and it means we're going to plug in is 1. You start kind of with your counting numbers or your natural numbers. So if n is 1, I just plug 1 in. Negative 1/2 to the first power is negative 1/2. So they want us to go all the way to 5. So we're going to now plug in n is 2. So negative 1/2 squared. I don't know why I can't put the 2 there instead of an n. When I square that, don't I get a 4th? A of 3 would be plug in n is 3, which, remember, doesn't this work just like x's and y's in a way? It's just a little bit different notation. And the reason it's different notation is sometimes they are going to add it. So they kind of have it in a way where they can describe that a little easier. Negative 1/2 cubed would be what?
Negative 1/8.
Negative 1/8. And then 4, if we plug in 4, negative 1/2 to the 4th power, it's going to be positive because the even exponent makes it positive. Wouldn't that be 1 over 2 to the 4th is 16, right? And you only have to do 5 of them. Negative 1/2 to the 5th power. It's going to be a negative number because it's an odd exponent. Odd exponent. So there's a leftover negative, and it would be 1 over 2 to the 5th, and 2 to the 5th is 32. You could make a table if you prefer and put n and a of n, and you could really see that it really is like plugging in an x and getting a y out, So if you like to do that, if that's more familiar for your brain, that's one thing some people do. The book doesn't do it, so I was trying to just show you what the book does. If you look at 43, the instructions say write an expression for the apparent nth term of the sequence. So what they're wanting you to do is come up with a sub n equal, is in that the nth term, in their terminology, they use n for your x's, and a of n tells you what your y value is. But remember, the reason they write it that way is so they can tell you what term of the sequence you're looking at. N represents a of 1 is the first term of the sequence, a of 2 is the second term of the sequence, and so on. One thing that you do when you look at this is, do you notice, like, what are they doing each time here? Adding 3. Okay, so I'm going to be adding 3 to something. And sometimes they'll put the 3 plus at the beginning. They are adding 3. Let me take that off for a minute. You got to kind of figure out how to do this, and this book does not give you a little formula to kind of help you out. Some places do. They're kind of approaching it a little bit differently. So we could think about it. It's like 3 times, is it 3 times n? If n is 1, 3 times 1 would be 3. Is that what the first term is? Is if we're adding 3 every time, it's almost like, quick adding is multiplication, right? If I say a of 1 is 3 times 1, am I getting the right number? No, I'm getting 3. It's 2. How could I get to 2? What should I do maybe? I'm sorry, we're trying to get to 1. How about subtract 2? Would that work? 3 times 1 is 3, minus 2 is 1. That's what a of 1 is, right? We can see it right here. We know a of 2 is 4. Let's try that. What if it's 3 times 2 minus 2? That would be 6 minus 2 is 4. We're kind of looking at patterns here. This is something a lot of times you get when you're just studying patterns, even in geometry. Let's see if this works. On the third term, n would be 3. 3 times 3 is 9, minus 2 would give me 7. Am I getting my series, my sequence here? Am I getting the right terms when I do this little thing I figured out here?
Yeah.
The numbers are working, aren't they? So couldn't I say that if I want the nth term, it's 3 times n minus 2? Right? Okay. So if you look at the difference up here, they were adding. This is what's called an arithmetic sequence. Every time you're just adding, or so you could be even subtracting something to get to the next term. So this is an arithmetic sequence in that they're adding something, or and it could have been subtracting something again. And so what they're adding or subtracting, if you think about it, this ends up, if you think of your n as your x, doesn't the 3 end up kind of being like the slope? Isn't slope the rate of change, right? And every time, isn't it changing by 3? So I could express this way, 3 times n minus 2, because my rate of change every time is add 3 or plus 3, and that's what your slope is. So a lot of times when I look at these problems, I use just the idea of slope to kind of think about how much is it changing every time. This only works when it's an arithmetic sequence. We'll have another day, we'll talk about geometric sequences, okay? And I think we did a little bit of this as some warm-ups a year or two ago. I can't remember, but you probably don't even remember this. I just did a few of these just to try to introduce you to them, just so they may not be so crazy later when you see them here in pre-cal. So I can represent it that way. That's one way I can write it. Now, some books have a different way of writing it, and they tell you to put the common difference. A of n is like the common difference, and they give you a little formula here. Usually you can figure it out if you just say, oh, I'm adding 3 every time, so that's my slope. And you're just kind of looking at it almost as like the equation of a line. You just don't have a y-intercept, so you're just trying to figure out, well, how do I adjust this number if I plug in 1, 2, and 3 to get the numbers up here? And usually it's just this simple. You go, well, the rate of change was 3, so 3 times 1 is 3, but I've got 1 here, so I need to subtract 2 to get to it. Now, not all of them are this way. Let me show you another one. For instance, if you're looking at, you're doing 42, 51 odd. Let's look at 49. That's a good one to look at. 49, what they're doing on these problems in this little part of the assignment is they're giving you a list of terms, and they're asking you, again, to write a little something that would represent it, and you're really looking for a pattern more than anything here. This one is not arithmetic. They're kind of focusing on a pattern here. I'm not adding the same thing every time. One of the reasons I know I'm not, doesn't it kind of go back and forth between a positive and a negative? Okay, so that's one way I know. So if I'm writing these things, again, look for the pattern. Isn't this, if you look at these numbers on the bottom, you're kind of always looking for things like squares and cubes. Aren't these, what are these things here? Isn't this like, if I think about it, isn't that 2 to the first power, isn't that 2 to the second power, and that's 2 to the third power, and that's 2 to the fourth power on the bottom? You kind of see what's going on here? They're just, each time, they're putting 2 to the next power, except they're alternating the signs. When you see signs alternating like that, you know you're going to have a -1, and it's either going to be to the nth power, or it's going to be to the n minus 1. Let's think about this. Let's first get the rest of it written. We'll come back to this. We may need to adjust this -1 to the n. I know I'm going to have a -1 there because that negative has to show up somehow. Well, you know what? Let's go ahead and talk about it now, I guess. Look at that first term. It's positive. This is n equal 1, right? If I had -1 to the first power, my first term would be negative. Is my first term negative? Mm-mm. So what I could do here is put -1. If I could put n plus 1, but then that may cause me some problems later. So I'm thinking, well, no, that might work. Let's try n plus 1. If I had -1 to the n plus 1, my first term would be -1 to the 1 plus 1. I can't get this. 1 plus 1. -1 squared would be a +1, wouldn't it? Don't I have a positive number on my first term? When I see this alternating negatives like this, it's almost like there's two pieces to this problem. One is dealing with a sign, and that's what I'm trying to figure out here, okay? And one will be dealing with, well, what's going on with the number part of it. So you have to break it into two parts. You can't usually do it all at once. Let's try this. If I had -1 to the n minus 1, let's say I'm on the second term. N would be 2. If I add 1, that would be negative 1 cubed. Negative 1 cubed would be negative 1. My second term is negative. Is this little thing working for me here? If I make, now we got to kind of think about what's going on with the numbers here. We noticed that we had powers of 2, right? This was 2 to the 1, and it's the first term. This was 2 to the 2, and it's the second term. What are you noticing about that exponent and the term? Aren't they matching, right? You see how they're matching? So what I could do to describe this would say, okay, it's 1 over 2 to the nth power. Right here, if I wanted to write my nth term of my sequence, this is how I could do it. We're just describing what's going on. We're trying to find a way to write down what's going on. Does that make sense? Let's do another one. Okay, so there's your terms. Here's what I do to help me, because I can't figure this out otherwise. Some people are really smart and they can do this in their head. I am not. I am like the slow but sure way of getting to the, this is n as 1, this is n as 2, this is n as 3, this is n as 4, this is n as 5. Okay, so I got 5 terms to kind of help me here. When I just look at the numbers, aren't they adding 1? Don't they start at 2 in the numerator, and they just add 1 every time? In the denominator, aren't they just start with 3, and they just add 1 every time? So somehow I have to, I go, all right, I can kind of see that's what's going on, and I've got, this is the first term, so I've got to relate it somehow to the n. It's like, how could I, remember, n is just like x. How could I plug x into something and get that? Well, if n is 1, to get to 2, wouldn't that be n plus 1, because 1 plus 1 would give me 2 in the numerator? And if n is 1 in the denominator, what could I do? Would it be 1 plus 2 is 3? So let's say, let's make a chart here. Let's say n, let's just try this out, and let's try this n plus 1 over n plus 2. Let's see if we're getting the right thing. Part of this is just playing around with numbers, which is kind of what makes you get better at math anyway, so this is a great place to try this. If n is 1, 1 plus 1 on top is 2, and 1 plus 2 on the bottom is 3. If n is 2, what would we get on the top? 2 plus 1 is 3, and 2 plus 2 on the bottom would be 4. Did that work? Yeah, so far so good. Let's try another one just to make sure this is going to work. If n is 3, 3 plus 1 on the top would be 4, and 3 plus 2 on the bottom would be 5. Okay? It's working, isn't it? Do we have any negatives to worry about here? There aren't any negatives on any of these, right? So we don't have that other little piece we have to worry about. When you see that alternating sign, you always have to do that little negative 1 to the n, or negative 1 to the n plus 1, but we don't have that here. So we figured out what's going on. Once we see that we're just adding 1 across the top and adding 1 across the bottom, we just had to figure out, well, how do I relate that to my starting number? My formula here would be n plus 1 over n plus 2. We figured it out and we saw that it worked. It's more just looking at what's going on and saying, okay, well, how can I get that? Always just start with your first term. That would be my formula there, and they just wanted you to, figure that out.